My seminar on Millau Viaduct, the tallest bridge in the world. Hello, I am Augustin. I am publishing this video because I was willing to present my seminar in front of all my classmates. But due to time shortage, they had class and our batch had seminar. So, during my seminar, only our batchmates and few students and two lecturers were there. And also, I had some supporting videos for my seminar in my PPT. But one of the software was missing in our project's computer. So I tried to connect my laptop to the projector, but it could not possible. So our guide told me to keep the laptop at the middle and to start my seminar. So here we go.
In this seminar, I am going to explain all these contents. Introduction. Millau Viaduct. It's a 2.5 km stretch bridge which is constructed across Tan River, and it has 4-lane roadway which is supported by 7 piers, and also it has highest pier in the world, and also it has unique pier structure that had never been attempted. You can see the curvature, that is 20 km horizontal radius. That first design was given by Michael Borlegax. He is a French structural engineer. That design was actually 9 piers. It has been reduced to 7 piers by Norman Foster, and that entire project has been picked up by Jean Perry Martin. Let's know about the statistics of that Millau Bridge. As I told, 2.5 km stretch with 7 piers, and its estimated cost was 450 million euros. And 77 meter is the shortest pier height, and 343 meter is the entire height of the second pier, that is the highest pier in the world, and 90 meter is the height of the mast. That's a portion of the pier above the road deck is known as mast, and 270 meter is the average height of that road deck, and 10 to 25,000 was the estimated daily traffic at that point, and 20 kilometers is the horizontal curvature as I explained. 120 years is the lifespan given by the designers. And this is the cross section of that road deck, and these are the height of the piers, each pier. And this is the pier detailing, that's height, and that shape will be changes from bottom to the top. And again the mast shape will be, this is known as mast, this shape will be changes from bottom to the top. While they started to construct, they came to know that geological formation around that site was completely full of cavities, just like shale or slate rocks. And if any delay in the construction process, that's the opening process, then it could cost $30,000 per day penalty for the entire team. And they were needed to change this shape of, this is the mode, actual mode. They were needed to change that entire mode over 250 times. And for every 3 days they were completing only 4 meters height, and to construct the world tallest pier they used GPS system, that is 4 mm accuracy. You can see here the red signal indicates the RL of fixed point on the ground, and these 3 blue signals are from the satellites, so that pinpoint accuracy will be maintained. And road deck was completely made up of 2,200 separate segments. I will show you the segments. And to cut and weld those bigger segments, that 2 plasma cutters were used. That concept had been come by concept of lightning, that is given by Nikola Tesla at the first time. And those 2 plasma cutters were working at 28,000 degrees Celsius, that is 5 times more than the Earth core. And when we heat solid, we will get liquid. When we heat liquid, we will get gas. When we heat gas, we will get plasma. That's the concept has been used, and for the accuracy of the cut and weld, again they use total station, whatever we use in our department. And these are the separate segments that are welded together. And after welding, that complete road deck was weighing around 36,000 tons. How to put that 36,000 tons onto the top of the pier? It's highly impossible. Either we have only 2 options, that to lift that or to slide it. To lift it 36,000 tons to that height is highly impossible. So they went for the second option, that's to slide that road deck. This is the one of the disaster that had happened in the Melbourne, Australia. While lifting that concrete road deck, that disaster had happened due to crane accident, and 35 people were died. And they used a tool. They prepared temporary structures in between the piers so that to support that road deck while sliding. And they used a launching system. These are the launching system which works. They slide the road deck one minute the other. Those two edges move that road deck up to 60 centimeter per cycle for every 4 minutes. On 26th February 2003, it was do or die day for the entire team. The first time they launched that system, no one had believed that it could move, but it has started to move. It was the happiest moment for the entire team. And further, it reached the first pier, and further it was the battle against the wind. Maximum speed of the wind was 130 km/h. Just imagine that with your normal vehicle speed. 130 km/h was the maximum speed, and since it has at some point one of the jack, that is launching system, stopped working. That cause was that the Teflon layer between those two edges were broken, and that left the road deck in the air. The entire team was afraid of, because since that road deck has wing-like structure, so that the air could easily lift it off. They were afraid of that, but they replaced all those Teflon layers between two edges, and they put the new Teflon layer. This is one of the video. If permitted, I will show you at then. And they analyzed that wind for 18 months, and after when the winds were blowing at less than 85 km/h, they went for the sliding process, that's to push that road deck. And in May 2004, that shorter span has reached its final position, but the longer span has to reach 2 days continuous push. That entire span came closer to each other, and that finished with within 1 centimeter accuracy. That is 99.9999% accurate. Of course, bridge and its entire construction process had over, but still problems were not at over. Problems were the undulations in the bridge. That's road deck. You can see here undulations. Those undulations become big headache for the entire team. But after stretching that mast and stretching those cables, that undulations luckily disappear. And every cable, single cable, have breaking point of 25,000 tons. And again, after preparing the road deck, that's road on the surface of the road deck, that extra added 10,000 tons to the entire bridge. And before opening that to the public, they need to be very sure that it should not cause any disaster, because mainly in the multi-span cable stayed bridge, what happens means when the load on the single span becomes high, then it makes alternative buckling, and that's up and downs in the alternative span. So they went for the test by 28 trucks, combined weight of 900 tons, and they placed at the critical point of the bridge, that is mid span, and they came to know that only 6 centimeter was the deflection. You can see in this video. Here you can see that's 26 centimeter was the only deflection. So it was a great news for the entire team. And we know that steel will expand and contrast due to heat. So since the entire road deck was made up of steel, when that expands, the piers will buckle. So they provided expansion joints. Again, let's consider this is the pier that we normally construct without any split at the top. Millau Bridge has split at the top, and when it is being stressed, okay, it is being stressed, it will reach up to 3 sticks, and it will get damaged completely. It cannot regain its original position. Let's consider this is one of the simple model of that Millau pier that I will show you. When it's being stressed, it reaches up to 4 sticks, and when that stresses were released back, means when the steel contrasts, then it regains its original position. This is the model of the pier that has actually used in the Millau Bridge, and it has finally opened on 14th December 2004 to the traffic. And I had told you to remember that value, that's daily traffic value was 10 to 25,000. But after opening this bridge, that has opened by President Jacques Chirac. And after opening this bridge, the daily traffic was 50,000 per day vehicles, 50,000 per day. That's more, and they collected $7 per car, which is a great news. Which was great news for the entire team. And within 9 months itself, and 7 lakh visitors were visited that site to see that impossible, which came to possible. And that was great news for the entire team and to the France. And conclusion. By using all the technology we have nowadays, we can use, instead of plasma cutters, we have laser cutters which are more faster than that plasma cutters. So nowadays we can use these technologies and we can build the unique structures and we can go up to more height. And these are the references that I have.
One point you told. So suppose you have conducted a test before using for public purpose. You have conducted a test. There are